With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start this question. Now in this question we have to arrange the order of the osmotic pressures of the equimolar solutions of the urea, BaCl2 and AlCl3. Now we know that we write the formula of osmotic pressure, that is represented by pi is equals to I into CRT. Now here I is the want of factor, I is the want of factor, and C is the concentration in terms of molarity concentration, R is the universal gas constant, and T is the temperature. Now we are given that equimolar concentrations, that means the concentrations are 1 molar and are same for urea, BaCl2 and AlCl3. Also we will take the temperature as constant, and we know that value of R is universal constant, so it means that the value of osmotic pressure pi will be dependent on the value of I, that is the want of factor. So we will calculate the value of I of all three given compounds. Firstly of urea. Urea is a non-electrolyte solution. Urea is a type of non-electrolyte solution. Now what does the non-electrolyte solution means? That it neither undergoes dissociation nor it undergoes any type of association. That is, it remains as it is. And this I is the calculation or the ratio of final number of particles to the initial number of particles. If it is not occurring any dissociation or association, then the value of I will remain 1. That is, for non-electrolyte solution the value of I is 1. Now we are given second case of BaCl2. Now let us suppose that it undergoes complete dissociation. It will give rise to Ba2 positive and 2Cl negative. If initially we suppose there are C number of moles of BaCl2, then final condition will be it will get dissociated into C moles of Ba2 positive, and for 1 mole of BaCl2 positive, BaCl2, we know that 2Cl negative ions are formed. So for C moles it will be 2C. Now we have to calculate the value of iota or I, that is the want of factor. Now this is equals to the ratio of final number of particles or final moles divided by the initial number of particles or initial moles. Now final number of moles are C plus 2C, that is 3C, and initial are C. So from here we will get the value of I is 3 for BaCl2. Now the third case we are given is AlCl3. AlCl3. Now if it undergoes complete dissociation, it will give rise to Al3 positive plus 3Cl negative ions. Now initially let us suppose it has C number of moles, so the final condition will be it will get dissociated into C number of moles of Al3 positive, and 1 mole of AlCl3 give rise to 3 moles for Cl negative ions, so C moles will give rise to 3C, and we will calculate the value of I, the ratio of number of moles, that will be C plus 3C 4C divided by C, that is initial, so it will be equal to 4. Now we know that the pi is directly proportional to the I, that is the osmotic pressure is dependent on the I. Higher will be the value of I, higher will be the osmotic pressure, and we have the maximum value of I in case of AlCl3, that is 4. So the osmotic pressure of AlCl3 will be greatest, and then we have the value of I as 3 of BaCl2, then the osmotic pressure will be of BaCl2, and at last it will be of urea. So this will be the order for the osmotic pressures for the equimolar concentrations. Now we have to choose the options. Now Al3 has maximum, then BaCl2, then urea. So the correct option will be option number A. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.